Hey, good afternoon, everybody. My name is Sumit Puri. I am the CEO and co-founder here at Liqid. And thank you to the Hello Show in Orange, Silicon Valley for hosting us today. And we're very excited to share with you a little bit about what Liqid does, specifically in an area that we refer to as composable disaggregated infrastructure. So today we're going to go a little bit over what the technology is, how the market is evolving. We'll cover a handful of the use cases that we are deployed in. We'll touch a little bit on how we're actually engaged with the team at Orange and some of the problems that we're trying to solve with them, especially around the AI market space. And then we'll kind of show you how all of this infrastructure interconnects and works and how we deliver the solutions to market and some of the market segments that we're playing in and the problems we're trying to address. So thank you for making time and listening. And with that, I'm going to go ahead and get started. So as mentioned, AI is a very important part of what is happening inside the marketplace. What we like to say is, AI is solving some of the most important challenges that the industry is facing today. Everything from bioscience to modeling to high performance computing, all of these aspects are actually being impacted and changed by the ability to implement AI inside of those workloads. So we'll talk a little bit on how GPU centric and accelerator centric workloads can benefit from the technology that we've developed here. And we're excited to kind of share the story around the evolution of the data center. So that's actually where we'll start. The slide that we're showing here is around the evolution of the data center. The kind of two key takeaways that we want to share from this slide is, number one, there is a transformation happening inside the data center. We are moving from statically configured infrastructure, which is actually configured at the point of purchase, to dynamically configurable infrastructure driven by software-defined everything. And today, the big buzzword in the industry is around technologies like hyperconvergence. As we go forward, the industry is starting to understand that disaggregation and composability is that next generation architecture that enables to address those next generation workloads. It's not just Liqid and Gartner that are talking about this. Even the CEO of NVIDIA, Jensen, is speaking of how the next generation data center is going to become disaggregated and composable. So I think it's important to maybe first understand how we define CDI, or composable disaggregated infrastructure. This is really a new way of building servers inside the rack. Rather than building our server by plugging devices into the sockets of the motherboard, with disaggregation and composability, it's all about fluid resource pools. So trays or pools of storage, pools of compute. These days, a lot of pools of GPUs, FPGAs, networking cards. We are truly hardware agnostic. We're not changing the hardware our customers buy. We are changing the way that they interconnect. And rather than taking those devices and plugging them into the sockets of the motherboard, with disaggregation and composability, we take those devices and we plug them into a fabric switch. And then we come in with software and we compose or we orchestrate at the bare metal. Grab me this 1U server, take those 4 SSDs, grab me those 20 GPUs, and build me a machine, build me a server. Just like we were plugging devices into the pizza box, except we're defining it in software. And on the other side, we're getting delivered a server, however big or small that our application layer requires. And most importantly, that server is dynamic. So if my application layer needs another GPU accelerator, we don't send somebody with a cart to power down physical hardware. All we do is we reprogram that intelligent fabric, and then we add or remove hardware depending on what the administrator or the application is requiring. And so for us, it's about changing the way that we interconnect the hardware inside the rack. And when we change the way that we interconnect it, we can make that from statically configured to dynamically configurable. And the first use case we like to talk about is with a very big transportation company that we work with, right? And if you think about the transportation-centric workload, 3 p.m. or 4 p.m. rush hour actually looks very different than 3 o'clock in the morning when nobody's on the roads. And right now, these guys play a game of workload matching. Small workload, small server, the world is happy and it's a good place. Small workload, big server, they're not utilizing their infrastructure appropriately. They're actually throwing away infrastructure and they're not getting the maximum value out of that gear. So Where they would like to get to is a point where they are studying the application, studying the workload on the inbound, dynamically spinning our machine size up, small, medium, large, extra large. We like to say however big the t-shirt size is required. And when that workload is done, we free that $10,000 GPU back out into the free pool so somebody else can have at that very expensive hardware. And for this customer, they're not trying to figure out, is dynamic better, is static better? We like to say everybody knows dynamic is better. This customer is trying to judge, am I going to own infrastructure or am I just going to put everything on public cloud, right? And at the end of the day, the value proposition that we are delivering with our platform is the cloud-like consumption model, the cloud-like agility model, the 4 clicks of a mouse and give me a machine however big I want. And when I'm done with it, let somebody else have at that resource and let them worry about it. And we give our customers that agility on infrastructure that they're responsible for. We give them much higher levels of performance than they would have gotten on public cloud. And oh, by the way, we can save them a ton of money doing it, right? So at the end of the day, it's not a matter of is cloud better, is on-prem better. We understand that the future is probably a hybrid model where some amount of my infrastructure lives on public cloud, but some amount of perhaps my mission critical applications that I run to make money from, maybe I want to own those and I want to run those on-prem. And what we're delivering is all of that agility that you get on public cloud, on gear that you own. So it doesn't matter if I'm doing it in cloud or if I'm doing it on-prem, we're going to provide that same agility and flexibility. This use case is around media and entertainment, maybe the easiest use case that we have to understand. And this one is very simple. This is a studio that also leverages these very expensive accelerators, these GPUs. And the model that they're implementing right now is during the day, they compose or give those GPUs to their AI engineers. And when they go home at night, they reprogram the fabric and they give those GPUs to their video rendering machines. They've taken $50,000, $60,000 worth of hardware, doubled or potentially tripled the utilization of that same infrastructure just by dynamically moving it around depending on where the hardware is most needed. And this was not possible until we got to an intelligent fabric that allowed you to reorchestrate the hardware. We like to talk about AI. We are a startup, and showing the big market opportunity that's related with AI is important to us. But at the end of the day, AI is a workflow, right? AI is not an event. So it's funny, we get people that come to us and say, "Hey, do you do AI?" Well, AI is multiple steps. AI starts with ingesting the data into your environment, and that's normally a network thing, right? Then we move on to the preparation of the data. This is the tagging, the cleaning, the scrubbing of the data, and that is normally a CPU intensive thing. And then we move on to what we call the training of the data, becoming intelligent on what the data means. And this is the big GPUs from guys like NVIDIA, 4 of them, 8 of them, 16 of them, as many as we can get in order to, what they say, reduce our training times. And then we move on to inference, which is yet a completely different hardware profile. And many times these are 4 separate servers and we're shuffling data between these different hardware profiles. And normally it's very, very big sets of data, petabytes of data. And so with disaggregation and composability, we can actually take a new approach. And this is an example of a solution that we've done with one of our partners, Dell. And this is a bundle specifically built and catered for AI type deployments. In this bundle, what we've done is we've delivered 4 compute elements, 8 GPUs, a handful of Mellanox networking cards, 32 terabytes of NVMe storage, all in this little 9 RU pod. And our customers can come in and do this any to any configurability. I am in the data ingest phase, give me the NICs. I am moving on to data training, give me the big GPUs. I'm moving on to data inference, give me that one other accelerator, right? And so this is how we're actually going off and delivering composability, is in the form of these solutions rather than delivering piecemeal. And another solution that we've built is the one that we're showing here, is around high performance GPU scale out. And this one's important to us is because this one we've actually done in partnership with the team at Orange. So there was a use case where we wanted to build a very, very high performance GPU centric solution. And so what we did is we took a standard 1U server, and to that we attached 20 GPUs. 20 GPUs is actually more than anybody else on the market can do today. And by being able to connect that many devices to a single compute, we actually delivered to market the world's fastest GPU supercomputer in a single machine. So it was a very compelling platform that we had put out there. We're actually getting a lot of interest from a handful of big hyperscale opportunities that want to leverage this solution. And so we're excited to bring the solution to market. And one of the interesting things here is not only are we going to take all of that GPU-centric horsepower and attach it to one compute element, but we're going to spread that around and make it available to either 2, 4, or 8 compute elements, so that not every workload is the same. So as workloads evolve over time and I need to change those ratios of GPU to compute, we're going to be able to do that dynamically on the fly. And on this slide here, what we're showing is the great work that we did with Orange Telecom. And on this one, we're very excited and very thankful to be able to work with the team at Orange. We actually wrote a white paper, a case study on this. And on this case study, we actually got NVIDIA involved with it, and we got our partners Dell involved with it. So this kind of goes to show the collaboration that we're doing out in the industry with big partners, big players, Liqid, Orange, NVIDIA, Dell. These are really important companies in the ecosystem, and we're bringing these disaggregated solutions to market in partnership with our very important strategic alliances. So with that, I'm going to kind of show you just one more example, and then I'll kind of conclude with where we are finding traction in our solution. One of the very exciting things that's happened for us is we're starting to get more and more traction in very large, what we refer to as HPC type deployments, high performance computing deployments. What you're seeing on the screen here is an example of a very big design win that we were awarded earlier this year with the Department of Defense. So again, this is built upon the original work that we had done with partners like Orange, NVIDIA, and Dell. And we have turned around and built large scale solutions around that fundamental baseline work that we had done earlier in the year. And the two wins that we're very eager and excited to talk about is one is with the Department of Defense Army Research Lab, and the other one is the Department of Defense Engineering Research and Design Center. These are two massively large machines built on disaggregated composable infrastructure. The first machine is actually 2 physical systems with a total of 100,000 compute cores and 300 GPUs built into a supercomputer. And then the second system is 85,000 cores and 600 GPUs, all as one comprehensive large supercomputing platform. And that actually ERDIC platform will become the 15th largest supercomputer on the planet. And again, we couldn't be more thrilled than we are with these wins. And these wins were built upon the good work that we have been doing with partners like Orange and NVIDIA over the last couple of years. So thank you to you guys, and we're very excited about what the future is bringing here. So I will close with this slide and kind of touch upon all the reasons why the industry is headed towards what we refer to a disaggregated data center. We spent a good amount of time talking about how we can dynamically move hardware resources around, but there's a bunch of other reasons why the industry is headed in this general direction. And I'll fly quickly through these because I think it's important to touch on them. So the first one has to do with scaling out the data center. What we say is the fundamental issue with hyperconvergence is that it's converged. As we scale out, I am going to end up with too much of one resource, not enough of another. As we disaggregate, this is the most efficient way to actually scale out the data center. So we can add trays of just GPU, we can add trays of just storage without paying for all of those other resources. The next one is we can extend the investment that the customer has already made. We can extend the product lifecycle of the gear that they've already bought. We feel rip and replace is dead. That's the old model. The new model will be, I will upgrade my GPUs independent from upgrading my storage, independent from upgrading my compute. All of these things we've broken down to independent life cycles. And by doing that, I am going to be able to extend the life of the gear. There's no reason to throw away my storage if all I want to do is replace my compute. We're going to decouple the purchasing decisions. If we go to our favorite server vendor today and we say, give me a box with 10 accelerators, they're going to say to you, here's quad processor. Well, that's not what I wanted. So through disaggregation, I can buy 10 GPUs with a single proc. I don't have to base one purchasing decision upon the other. The next one is we can enable that impossible configuration. As we showed with the product with Orange, if we want a server with 20 GPUs in a disaggregated world, we can do that. And we're not bound by the limitations of the physical sheet metal, right? I can basically create any configuration required by my application there. The next one is really the advantage of pay as you grow. We would like to pick on storage here. NVMe storage and SSDs and storage in general gets cheaper quarter on quarter. In a disaggregated world, I don't have to pre-buy everything. I can buy these resources as we go forward in time and therefore be more efficient. And the last one is software licensing, right? Right now, how do we consume software license inside the data center? I buy an x86 processor with a software license attached to it. When I need more physical resources, I buy another processor and I pay for more software. In a disaggregated world, we take a different approach. When my server needs more resources to virtualize on top of, I don't pay for more software. I just reconfigure the underlying hardware underneath. So these are all the reasons why we as an industry are headed towards this model of disaggregation and composability. And these are the workloads that are benefiting from this, AI-centric workloads, the ability to do cloud workloads with dynamic infrastructure, the ability to do high performance computing based upon a composable environment. And we're seeing it today with the move to 5G, cellular infrastructure. The long distance phone call back to core data center doesn't work anymore. And now we're being forced to push infrastructure out to the edge that can also benefit from being composable. So thank you, everyone. Hope you enjoyed that information and that update. There was a lot of information here, and we encourage you to go into your chat window and ask away, and we are happy to address any questions you guys might have. Thank you.